Hello. Good evening to all the participants.
Good evening, sir.
Yes, I hope that my voice is audible.
Yes, sir, it's audible.
Yeah. So if there is any issue with the connectivity, kindly let me know. I will switch to another. There is a network issue right now. I can, if the network is not clear, I can switch on to another network, so that we can have a session without any interruptions. So this week, there were a lot of questions, lot of mails regarding the detailed solution. So our team is working on it. So we will make sure that it will be made available to all of you as soon as possible, so that you can prepare for the examinations. Uh, Thanks for your understanding and patience. So with that, I would like to start the session. Um I welcome you all once again to this live interaction session. Uh, this course is brought to you by NPTEL. The title of the course is Advanced Reinforced Concrete Design, and this course is being instructed by Professor Surya Prakash of IIT Hyderabad. And presently we are in the 8th live interaction session, and this session is going to be presented by me. My name is S. Lalit Sagar. I am a doctoral candidate and PMRF fellow in the Department of Civil Engineering at IIT Delhi. Okay, so were there any questions from this week's lecture or previous week's lecture? Hello. Hello.
Yes, sir.
Yeah, I hope my connection is proper. Like if there is any interruption, I can actually switch the network.
Yes, sir.
Okay. Okay.
Still, your
Okay.
screen is not visible.
Is it not visible? Oh. Okay.
Yes, sir,
Okay.
it's not visible.
Okay. Okay. Yeah. Thanks for sharing. I will. Yeah. Hello. uh, yeah, I'll start presenting. Please let me know if the screen is visible. Okay. Is my screen visible?
Yes, sir.
Okay. So in week 8, actually we are dealing with the topics of the shear and torsion. So since we have lot of topics to cover, because last week there was a part of the module on shear that had to be covered, but I could not cover it last week. So this week I'm going to be taking up the topic of shear as well as torsion in flexural members. So since we have to cover a lot of topics, I'm going to go ahead straightly with the question and answers. If there is any doubts from the lecture, feel free to ask me. If not, we can start with the presentation. We can start with the question and answer session now.
So I have a question related to shear span. Can I ask now?
Yeah. Please go ahead. Yes.
In the lecture, Professor Surya Prakash sir discussed about the shear span
Yeah.
for the beam subjected to point loading P.
Yes.
What should we do if in the case the loading is UDL?
Okay.
So how can we determine the shear span and so that we can calculate the A by D ratio? So can
Okay.
you please suggest?
Yes. Yeah. Thanks for the question. I'll try to locate that particular slide so that I can explain that. Right. Essentially, shear span corresponds to the ratio of this A by D. That is, if you consider a simply supported beam uh, with hinge support here and a roller support here, then if we consider two symmetric point loads acting on the beam at a distance A, so shear span is given by A, and the ratio of this A by D. Yeah, I think it is. Yeah, so if you can see here, F by tau is proportional to A by D. So as what we saw in the lecture is that as the value of A increases, your flexural stresses become more prominent. However, if the value of D, if it becomes a D beam, then the value of A by D is going to reduce, and then the value of tau is going to increase. So uh, I can just say that the concept of shear span was introduced in order to discuss about the significance of the location of this point load on the development of flexural or shear stresses. Okay, so it is particularly considered a point load because we wanted to get uh, a particular length of the beam which was under a constant bending moment. Okay, so I think that was the point of it, and actually that is only to to give an idea as to how the stresses develop in a beam, whether it is flexural or shear stresses, depending on the location of P. And I think that was the only point, and I don't think it is really important if you consider a UDL. Hello.
Oh, okay, sir.
Yeah, because that concept we really don't use the shear span later on. So according to my understanding, it was only to to highlight what would be the influence of the location of this point load on the development of the stresses, whether the flexural stresses will be predominant or the shear stresses. So yeah, that is my understanding, but I would like to get back to you. I will make a note of it, and I will see if there is any significance of UDL on this shear span.
Thank you so much, sir.
Yeah. Thank you for the question. Are there any questions? Any further questions?
No, sir. It's
Okay.
okay.
Okay. Thank you. So we can start with the question and answers now. Yeah. So we are going to discuss certain questions on the shear and torsional behavior of flexural members in this particular session. As usual, it is going to be a combination of conceptual and numerical questions, and yeah, as we have seen in the previous sessions, we are going to be leaning a bit more on the numerical side. So I hope that you will enjoy the questions and learn about the shear and the torsional behavior of flexural members. Okay, so we'll start with the question number 1. So it is related to the flexural and shear behavior of a beam. Which of the following statements are correct regarding the flexural and shear behavior of a beam? Okay, so there are 5 options, and we need to select the correct options among these 5 statements.
Options C and D.
Okay, is that option C and D? Is that what you said?
Yes, sir.
Okay. Okay, so I think we can look at the answer. So yeah, as you mentioned, it's absolutely correct. Option C and D is the right options. Right. Yeah, just a brief explanation before we move on to the next question. So option A is incorrect because here the terms of flexural cracks and shear cracks are interchanged. So the flexural cracks are developed normal to the longitudinal axis, while the shear cracks are developed in a diagonal manner. And here option 2 is incorrect because shear failure is more dangerous compared to the flexural failure because it occurs without giving us any warning. And option C is correct because in RC beams we want to ensure that the shear failure does not occur because it is more brittle in nature. And option D is also correct because in order to estimate the shear resistance by a beam, we generally require the amount of tension steel that is provided, which we are going to discuss in later questions also. And option E is incorrect because generally it is not the shear force, it is the torsion which is being converted to the equivalent bending moment, and then it is designed for the corresponding bending moment and shear force. So option C and D are the right answers. Okay. Yeah, so here is a representation of the flexural and shear cracks from the lecture slides. So we'll move on to the next question. So in the reinforced concrete beam shown below, which type of cracks appear in the region C under a uniformly distributed loading? So we have 6 options. One of them is the correct answer.
Yeah,
Option
flexural.
I'm sorry, can you repeat?
flexor and
Mainly.
flexural shear.
Okay, option E. One of them is telling option E.
Option E.
Okay, okay, okay. Thank you for the response. Okay, so I think we can look at the answer, and yes, option. Okay, I think there is a mistake actually. So it has to be option E. Option E is the right answer, right? So sorry. Option E is the right answer, because what we have seen here is a reinforced concrete beam that is simply supported on one end and it is continuously supported on the other end. So here the bending moment is 0, but shear force is very high. So in region D it is predominated by the shear cracks, and in region A I think we can see the here in region A it is subjected to hogging bending moment. So there is flexural cracks, and since it is close to the supports, it is subjected to shear cracks also. So it is a combination of flexural and flexure shear cracks. And if we look at this region B, so region B is predominated by the web shear cracks, because as we can see it is not subjected to very high bending moment. And if we see the region C, has since it is covering a larger part of the span, so it consists of flexural cracks, as we can see here, which are perpendicular to the longitudinal axis, and we also have this flexural shear cracks, that is they are initiated in the beginning either as a flexural crack or a shear crack, and then they also become flexural shear cracks. For example, if you consider this particular crack, because of the high shear force, we can say that they initially develop as a shear crack, but later on, because of the extension of the flexural cracks, they tend to become flexural shear crack. So option E is the right answer. Okay, moving on. So we have a numerical here. So consider a homogeneous beam of width 250 mm and overall depth of 500 mm. So a critical cross section of the beam near the support is subjected to a shearing force of 400 kilonewton. So what would be the average shear stress in the cross section? Okay, kindly take 30 seconds to 1 minute to answer this question.
Answer B.
Okay, answer B. B is it, or D? B for Bangalore or D for Delhi?
Bangalore.
Okay. Okay, thank you for the response. Any other participant would like to confirm? Other participant would like to confirm, please? Okay, if not, we can go ahead with the answer. So yeah, option B is the right answer, and I think it is quite straightforward. So what we need to determine here is the average shear stress, that is tau average is equal to VU by B into D, right? So we consider this as the factored shear force, right? So we have 400 into 10 to the power 3 divided by 250 by 500. So this gives us a value of 3.2 megapascal. Okay, so option B is the right answer. So we can move ahead with the next question. So for the same beam that we considered earlier and having the same geometric properties and subjected to the same shear force, what would be the shear stress at a depth of 150 mm from the top compression fiber? Okay, kindly take 1 minute and let me know what would be the answer. So 1 minute is up, so I would like to provide a hint. So we need to determine the value of shear stress. So as the participants might be knowing, shear stress is given by V into Q divided by IB. Kindly take another minute, then we can look at the solution. Okay, so 2 minutes are up. Are the participants trying, or shall I go ahead with the answer? Okay, I think we can go ahead with the answer. So the correct answer is option C. So we will look at the how to solve this particular problem. So this is beam having a dimensions of 250 by 500, and it is given that the shear force is 400 kilonewton. Okay, so since it is a homogeneous beam, yeah, we will take the neutral axis at this location. Okay, and we need to determine the shear stress at a depth of 150 millimeter from the top compression fiber. Okay, so since it is 500, so the depth of this, this mid depth would be 250 mm, right? So this would be 250, and we need to determine the shear stress at this particular location. Let us call this axis as xx. Okay, so the shear stress, as I was mentioning, it is given by V into Q divided by A into I'm sorry, it has to be I into B. I into B. So this what is Q? Q is given by the moment of the area about the section or about the layer we want to determine the shear stress. So we need to consider this particular region in order to calculate the moment of the area. So this is 150, right? So Q is given by, so we need to find out the moment of the area about this axis xx. So that is given by, first the area is 250 by 150, okay, and the centroid of the area taken about the x axis is 150 by 2. So can anybody calculate and tell what would this value be? Okay, and I is given by, yeah, please go ahead.
2812.500.
Yeah, 2812.5.
5.
Yeah, thank you. 10 to the power 3 millimeter cube, and I is as we know, for a rectangular section it is BD cube by 12 by 12, that is 250 by, so for the I we need to consider the entire depth of the cross section, and this would be
2604.1.
yeah, thank you.
Ten to the power 6.
Thank you. Yes, so we have this value of I, and B we know that it is the width, so we just calculate, substitute the values, 400 into 10 to the power 3, right, into Q would be 2815 2812.5 into 10 to the power 3 again, divided by 2604.167 into 10 to the power 6 into 250, which gives us a value of
1.72.
yeah, thank you. So this is the shear stress at this particular, like as we have seen, we'll be discussing later also. So if this is the cross, let me take a different ink, right? So we have seen in the lectures also taught by sir, that if this is the cross section, and we saw that the flexurals, it can vary, something like this, corresponding to the concrete, this would be concrete and this would be this thing, steel. But if you consider the shear stress, so it shows a parabolic variation. So we determined that, you know, corresponding to the entire cross section, we got average, tau average we got as 3.2 MPa, and so, but if we consider this point section XX, so the value is 1.728 MPa. Okay, so we'll move on to the next question. So for the same beam that we considered in questions 3 and 4, what would be the shear stress at the mid depth of the cross section? Okay, so one hint is that we need to consider XX at a depth of 250 mm, okay, right in the middle of the cross section. So kindly take 30 seconds and let me know the answer.
Answer E.
Okay, thank you for the response. Anybody else would like to confirm? Okay, so I think we can go ahead with the answer. So yeah, option E is absolutely right, and essentially, you know, there are two ways of, you know, solving this problem. So the first method is, you know, as we discussed in the previous problem, so we got this by the formula V into Q divided by I into B. So in this particular expression, all the variables are going to remain the same from question 4. V is same, I is same, even B is same. However, the Q, the moment of the area about the axis considered, that is going to vary, right? So we are going to consider this part of the cross section, and we are going to take the moment of that part of the section about the XX axis. Okay, so this would be 250, right? So Q would be 250 by 250, taking moment about the axis XX, 250 by 2. So that would, you know, give, and when we plug this value in this particular equation, so let me just calculate what would be that value. So I think Q comes out to be 7812.5 into 10 to the power 3 millimeter cube. So when we plug the value of Q in this particular equation, we get a value of tau is equal to 4.8 MPa. Okay, I request all the participants who are, you know, watching this online recording to you know, to check and see if they are getting this answer. And there is another way also, you know, to solve this problem, that is this we consider, if we take this as the cross section, so it follows a parabolic distribution. So this would be the actual distribution, right? But we consider an average value. Okay, we instead of consider the parabolic distribution, for the ease we take this average stress. Okay, so we consider a rectangular distribution that is equivalent to this parabolic distribution, right? And this value would be tau average, and this particular value at the mid depth, that would be tau max. So the simple relation between these two terms is tau max is equal to 1.5 times tau average for a rectangular cross section. Okay, so this particular equation holds for a rectangular section only. Okay, so the simple way, that is, we are discussing the second method, is that you obtain the value of tau average, which we got from question number 3. So we got the value of 3.2 MPa, and we just multiply it by 1.5. Sorry, 1.5 into 3.2, which gives us a value of 4.8 MPa. Okay, so option E is the right answer. So we can proceed to the next question. So it is a theoretical question regarding the internal shear resistance of a reinforced concrete beam. So which of the following does not contribute to the development of internal resistance or shear stress in a reinforced concrete beam with transverse reinforcement? Okay, so there are 5 options, and one of the options is does not contribute to the development of shear stresses in a RC beam.
Option D.
Okay, thanks for the response. And yes, we can go ahead with the answer. So option D is absolutely right. So in the lecture, we looked at the mechanism of the development of shear stresses, which was very interesting. So we saw that essentially the contribution to the shear resistance comes from two components, that is broadly two components, that is concrete, that is denoted by this term VC, and by the stirrups. So stirrups, it is indicated by this VS, right? So within the contribution by concrete, so the concrete contribution is considered as a summation of VCZ, that is the shear contribution by the concrete in its uncracked state, right? So that's the first component. Then we have VA, that is the resistance provided by the interlocking of aggregates within the cracked concrete, right? And then we have VD, that is provided by the double action by the longitudinal rebar. Okay, so the double action is essentially the longitudinal reinforcement provides resistance to the extension of the cracks that is being formed within concrete. Okay, so all these 3 constituents, that is uncracked concrete and the shear locking of the aggregate and the double action by the longitudinal rebar, together constitute the shear resistance provided by the concrete. Okay, so that is what we are seeing here. So the VC is the summation of these 3 components, and further, in addition to these 3 components, there is the shear resistance provided by the stirrups. Okay, so as we can see in these questions, so option A, B, C and E together account for the shear resistance provided by a reinforced concrete beam having transverse reinforcement. Okay, so option D is the incorrect option, and hence it is the right answer for this particular question. So moving on, so as per IS 456, the shear strength of concrete within a reinforced concrete beam depends on which of the following factors. So there are multiple options, multiple correct answer for this particular question. So just to give the participants a hint, there are two correct answers in this particular question.
Option A and C.
Okay, thank you for the response. Anybody else who would like to contribute? Okay, I think we can look at the answer, and as the participant mentioned, option A and C is the absolutely right answer, because so here we have the slide taken from the lecture, and the magnitude of design shear strength tau c. So tau c is refers to the resistance, shear resistance provided by the concrete. That depends on various factors that are in turn related to primarily two factors predominantly, that is the grade of concrete and percentage of tension steel. So here we have to be really specific, because there is just longitudinal reinforcement will not be the appropriate answer. So we need to be specific, and we need to mention that it is the grade of concrete and the longitudinal reinforcement in tension. These two factors are responsible for the development of shear strength of concrete. Okay, so this is from the lecture slide, and we can see from the table 19 provided in IS 456 also. So we need to determine the value of tau c based on the table, and the value of tau c essentially depends on two factors, that is the concrete grade. So for M15, M20, 25 and so on, the values are different, and here the term 100 AS by BD corresponds to the percentage of tension reinforcement. Okay, so options A and C are the right are the correct options. So we'll move on to the next question. So as per IS 456, what is the influence of axial forces on the design shear strength of concrete?
Option D.
Okay, D for Delhi.
Yes, sir.
Okay, thanks for the response. We can look at the answer now, I think. So the correct answer is, in fact, it is option B, because when the axial compression within a beam increases, that leads to enhanced shear strength. Okay, so yeah, so this is taken from the lecture slide, and also in the table 19 of IS 456. So it is given that whenever there is an axial compression, axial compressive force Pu, that is acting on the member, the design shear strength of concrete has to be multiplied by the following factor. So that is usually that is actually greater than 1, because 1 plus, and this this is a positive term, and 1.5. so essentially whenever there is a compressive force acting on a beam, that leads to the increase in the shear strength. However, it has to be limited within 1.5. so even if this particular term comes out greater than 1.5, let's say 1.7 or 1.8, we need to take the lesser of these two values. Okay, so it is limited by multiplication factor of 1.5. okay, let me make the correction here. 456 2000. okay, so moving on. Yeah, so this is an applied question from what we learned in the class, in the lecture last week. So if we consider an interior beam column joint, the beam has to be designed for shear. If the beam is subjected to a load of 500 kilonewton at 50 centimeter from the column face, what is the location of the critical section for calculating the shear force? Okay, and we need to give the location of the critical section for the shear force, and it is given that the depth of both beam and column are 40 centimeter each. Okay, kindly take 1 minute and let me know what you think is the right answer.
Option E.
Okay, thank you for the response. We will wait for the other participant if they like to answer. Okay, so I think we can look at the answer now. So as the participant mentioned, the option E is absolutely right, and it is given here. So we are in the problem, it is given that we are considering an interior beam column joint. So we'll be dealing with the beam column joint in little more detail when we discuss about the columns. So let us consider that we are having a column here, and this is beam. Okay, okay, so so it is given that a load of 500 kilonewton is acting on the beam at a distance of 0.5 meters. Okay, so it is given as per the IS code that whenever there is a heavy point load that is acting on the beam which is within a distance of 2d, so what would be the value of 2d? So we have the overall depth of the column, overall depth of the beam as, let me mention with the suffix b. db is 400 mm, right? So if we consider an effective cover of 50, we can say that the effective depth would be 350 mm, and 2 dB would be 700 mm or 0.7 meter. Okay, so as per the IS code provisions, since the heavy load is acting within a distance of 2d, okay, from the beam column interface, right? So this, since this is less than 0.5 meter, is less than 2d, right? So we need to consider the critical section at the beam column interface. Okay, so let me just highlight in a different color. So we need to consider the critical cross section in order to calculate the shear force. Let me call it XX. Okay, so the critical section has to be taken at the face of the column, and hence option E is the right answer. Okay, moving on. Yes, so we will start with more rigorous and involved numericals now. First we are going to be dealing with the design for shear force, then we are going to design for torsion. So as per the question 10, we consider a rectangular RC beam of dimensions 300 mm by 600 mm and having a span of 4 meters. The beam supports a factored load of 60 ton at its midspan. The beam is reinforced with 4 bars of 20 mm diameter of Fe 500 grade. What would be the design shear force for the beam? Okay, kindly take 1 minute and let me know what would be the correct answer.
$300. Option A.
Okay, thanks for the response. The other participant, would you like to confirm? Okay, I think we can go ahead with the answer and the solution. So yes, as you mentioned, option A is absolutely right. So it is quite straightforward. Let me draw this. Let me draw with the help of the illustration. So we have a reinforced concrete beam. So it has to be simply supported. I forgot to add that information, but I suppose that is implied because we are dealing with statically determinate structures for the analysis here. So this is subject, I'm sorry, we have a, this is simply supported, and it is having a span of 4 meters, and the load is 60 ton or 600 kilonewton, right? And we can very easily, since it is symmetrically located, it is at its midspan, we can very easily write that the reactions at each support would be 300 kilonewton. Now if we draw the SFT, I'll take a different color. Okay. So if we draw the SFT now, so positive 300, and it's going to remain constant up to the location of the point load, and it's going to go down by 600 kilonewton. It's going to remain constant once again, only to go up and reach its. So we have 300 and it is minus 300. Let me just hatch the portion. So this is our SFT, which is in kilonewton. Okay. So the design shear force for the beam is going to be 300 kilonewton. Okay. So now the question is, for the beam that was given in question 10, what would be the spacing of transverse reinforcement considering two-legged 10 mm stirrups of grade FE 500? Okay. So one hint for all of you is that kindly note down the reinforcement that is provided. So we have 4 bars of 25 mm diameter. So this value of PT is going to help us in evaluating the value of tau c, that is the shear contribution in concrete. Okay, so kindly consider this particular configuration of stirrups, two-legged 10 mm stirrups, and let me know what would be the spacing of transverse reinforcement. Kindly take 1 to 1.5 minutes, then we can discuss the solution and the answer.
C 164.
Okay, option C, sir.
Yes.
Okay, thank you for the response. So any other participant would like to confirm the answer? I think we can wait for another 30 seconds and then we can look at the solution.
while calculating beta,
Yes.
the formula is whether it is 0.8 in FCK or 0.8 FCK. Because in that presentation, both are given. One formula is given 0.8 and it is given 0.8.
Okay. So what is the confusion, sir? Like, is it 0.8 or 0.9?
0.8 or 0.89.
No, no, it has to be 0.8.
0.8, na? Okay.
Yeah, yeah.
Because in the presentation it is given 0.89. So many there.
Okay, okay, okay. So in that case, what I do is, I will check with the table 19.
Yeah, actually ISI was not checked. It is a class.
Yeah, yeah, yes, sir. So if both are matching, then you can be sure, you can be assured that the that is correct. So I have calculated using both. So we will see the answer. So I think we can go ahead with the answer. So actually the answer is option D, that is 169. So we will look at the detailed solution now. Right. So I'm going to write down the steps since it is the first problem where we are designing the beam for shear. So here, okay, I'll take a different color. So I'm going to write here. So in the form of steps. So step 1, basically we drew the SFT, right? And then step 2, in step 2 we need to determine the nominal shear stress acting on the beam. Tau V is equal to Vu by BD, right? So as we saw earlier, the dimension says 300 by 600. So I'm just going to draw the cross section here. By 600. So I'm going to assume that the the effective cover is 50 mm. So we'll take the value of effective depth as 550, right? So Vu is 300 into 10 to the power 3 by 300 by 550. So this gave me a value of 1.82 MPa. Okay, so step 3, we need to check for the adequacy of the cross section, which is we obtain by looking at table 20. So this tau V has to be less than tau C max, that is the maximum permissible shear stress in concrete. So for M30 grade we get a value of 3.1 MPa. So 1.82 is less than 3.1 MPa, so the cross section is adequate, right? So we can write adequate or okay.
3.5 is that was nice. For M30.
Okay, let me check. I think it is 3.1. Okay, I think I need to go to the IS code is not open, so
3.5.
what is the page number? I think okay, so yeah, so we have for M30 concrete it is 3.5. yeah, thanks for your input. So for M30 it is 3.5 MPa. So it is
And cover you have not mentioned, sir. Actually, cover is not mentioned. No?
Yes sir. So I have assumed it as 50 mm.
So I was assumed 40 mm.
Okay.
Then how was the correct answer will get assessed?
Yeah. So
That 5 mm difference will come, sir.
yeah, right. Yeah.
So it is ambiguous, this type of questions.
Yeah, so like yeah, that happens quite a bit. Yeah, we will make sure that at least in the assignment it is not there. Okay, so I don't think, I'm not sure, but maybe 10 mm, I don't know. Okay, we will look into the solution. So yes, it has to be less than 3.5 MPa. 3.5 MPa, right? Then we proceed to the step 4. So step 4 is to calculate the shear resistance of concrete. So that is tau c. Tau c is a function of PT and grade of concrete, right? And PT is given by 100 into AST by BD. Okay, and we get a value of 1.19%. okay, and FCK is 30 MPa, right? And from the table, from table 19, okay, we get the value of tau c as, I got the value as 0.70 MPa. okay, so this can be ascertained using the equations given in the slides also. So when I use this particular equation, so we have tau c is equal to 0.85 under root 0.8 FCK into root of 1 plus 5 beta minus 1 divided by 6 beta. Okay, so we have beta, there are two values, 0.8 FCK by 6.89 PT and 1. So we need to consider whichever is higher between these two values. So when we plug the values, we get the value of tau c as 0.70 MPa, right? So here when we compare these two values, tau v is 1.82 but tau c is 0.70. so we have to design the shear reinforcement. So we need to move on to the step 5. So step 5, since tau v is greater than tau c, so we have assumed, we have given the data as two-legged 10 mm stirrups. So ASV is given by pi by 4 into 10 square into 2, so which gives us a value of 157.08 mm square, right? So we will before going there, we need to determine the force for which the steel has to be designed. Vs is equal to Vu by Vuc, so that is 300 into 10 to the power 3 minus tau CBD, that is 0.7 into 300 into 550. Okay, so that is 184.5 kilonewton, right? So we have the expression for spacing of stirrups, that is SV is equal to 0.87 Fy into ASV into D by VUS. So when you plug all the values, we get the value of SV as 169.07 mm. Okay, so after this we have one last step where we need to check for the other values of the minimum spacing that needs to be provided. So that is step 6. So SV has to be at least it has to be at least 300 millimeter, or it has to be minimum of 0.75 D. So I got that value as 412.5 mm, and we have a third expression, that is SV should be less than 0.87 Fy into ASV by 0.4 B. So for this I got a value of 473 millimeter. So for this particular beam we can finally provide stirrups at a spacing of course the correct answer is 169 for the data that I considered, but we can ultimately say that we provide two-legged 10 mm diameter stirrups at 150 center to center, because it is desirable to provide the stirrups at a spacing of 25 in multiples of 25 mm. So this would be the correct answer. Okay, so option D. So we will move on to the next question. So in the previous question we looked at a point loading. So now we will consider a UDL for a RC beam of dimensions 300 by 600 mm and a span of 6 meter. It is supported by a factory UDL of 90 kilonewton meter, and the beam is reinforced with four bars of 25 mm diameter. Determine the design shear force for the beam. Okay, so kindly take 1 minute and let me know what would be the right answer.
Answer E.
Okay, so I would like to just remind that we need to consider the shear force at the critical section. Okay, so kindly take the critical section carefully. Okay, so I think we can go ahead with the
Answer
answer.
answer C.
Yeah. Okay. Yeah, so option C is the right answer, because as we were discussing earlier also, regarding the problem with beam column joint, we need to consider the critical section. So let me draw a sketch very quickly. So we have this simply supported beam. Okay, so it is given that the center to center spacing is 6 meter, right? So it is supported by a UDL throughout. So this would be 90 kilonewton per meter. So this is the reaction. So the reaction is, as you mentioned, absolutely it is right. If we take that it is point A and B, RA is equal to RB is equal to 90 into 6 divided by 3, that is 270 kilonewton, right? But we need to take a critical section which is at a distance D from this point. So we will take it as let us consider it as XX, right? So we will take this value as VU. VU is equal to 270 minus UDL is 90, and we will take it as considering 50 mm as the effective cover, we can take it as 0.55. So for which we get a value of 220.5 kilonewton. So now the next question is, considering two-legged 8mm stirrups and grade of steel as 415, determine the spacing of transverse reinforcement. So the reinforcement is same as earlier also, so I have given all the data. So what would be the spacing for this particular question, for this particular beam? So I hope that the participants are trying to solve this question. Okay, anybody was able to get the answer?
No.
190B.
Oh,
190.
Okay. Anybody else would like to confirm? So one of the participants has said that option B is the right answer. Anybody else would like to confirm? I'll wait for another 30 seconds. So the steps are right in front of you. Okay, I think we can start the solution. So tau v is given by VU by BD. So what is the answer for tau v? So yeah, let me tell the answer first. So option D is right. So what would be the value of tau v? What would be the value of tau v?
And 001.
Okay, so it has to be 1.336 MPa. Tau is, and tau c max is, for M30 it is 3.5 MPa, right? And PT is given by 100 into AST by BD. AST by BD, that is comes out to be 1.19%. And instead of I use the table directly. So for M30 concrete and for 1.19%, based on the interpolation between 0.66 and 0.70, we obtained a value of 0.698 and approximated it to tau c is 0.70 MPa, right? So VC is tau c into BD, 0.7 into 300 into 550, so I got a value of
115.
yeah 115.5 kilonewton, right? So VUS is VU minus VUC, so 220 minus 115, that came out to be 105 kilonewton, right? So in order to find out the spacing, we need to find out the variables here. So plug all the values here, 0.87 into Fy, so we need to take it as 415. Even if it is 500, we need to consider 415 into 100.53 into D by VUS is 105 into 10 to the power 3, so which gives us a value of 190.12 millimeter. So I think this will it makes the process very crystal clear as to how to go about. So first we find out the value of tau c, then we check with the value of tau c max to check the adequacy of the cross section, and if the tau e is exceeding tau c max, then we need to provide higher dimensions for the cross section. Then we proceed to find out the value of PT, that is the percentage of tension reinforcement. Then based on the value of PT and FCK from table 19, we obtain the value of tau c, that is the shear resistance provided by the concrete. Then we find out the value of VUC, the resistance in terms of the force, that is tau c BD. Then we determine the value, the force for which the stirrups must be designed, that is VU minus VUC. We got 105 kilonewton. Then based on this expression, we just plug the value of Fy, ASV, D and VUS. Then we obtain the value of SSV, and this has to be this is the minimum spacing that needs to be provided. So from this we can say that based on the forces that were applied on this beam, we can provide two-legged 8 mm diameter stirrups at 175 mm center to center. Okay, I have forgotten to add we can provide two hanger bars of 12 mm diameter, and yeah, we need to provide hooks for the stirrups. So this is the option B is the correct answer. Okay, without any further delay, we will move to the next problem, and we are going to solve few questions on the torsion. So we consider the same rectangular RC beam. So it is subjected to a factored torque of 75 kilonewton meter. So determine the area of longitudinal steel required for the beam. Take FCK as 30 MPa and Fy as 500 MPa. Okay, kindly take 2 minutes and let me know what would be the correct answer. I am going to draw the sketch and data side by side. Here also take the effective depth as 550 mm. So I have written the sequence that needs to be followed in order to ultimately determine the value of AST.
Answer C.
Okay, thank you for the response. Yeah, anybody else would like to confirm? So we will wait for another 15 seconds, then we can proceed with the answer. Okay, so yeah, option C was the right answer. It's absolutely right. Yeah, as I was mentioning, the procedure is right in front of us. So first, in order to design for torsion, so there are two aspects. First, we need to design for the longitudinal reinforcement, and then we need to design for the transverse reinforcement. Okay, so we are dealing with the first aspect, that is longitudinal reinforcement. So we will convert the torsion into an equivalent bending moment given by this particular equation. Mt is equal to Tu into 1 plus d by b by 1.7, for which we get a value of Mt as 132.35 kilonewton meter. Okay, so after that we need to consider this equation. Me1 is equal to mt minus mu, and since there is no bending moment acting on the beam, so me1 becomes 135 kilonewton meter. So R is given by mu by bd square. Okay, so this value would be 1.458 MPa. Okay, and we need to check this with the value of mu limit by bd square, mu limit by bd square, to check whether the cross section is adequate, and this was coming out to be the expression is 0.138 FCK, which is 4.14 MPa, which is fine. It is and can be designed as under reinforced cross section. Okay, I think I need to read erase this one, so this is not given. Okay, right, so I just wanted to say that we need to consider an effective depth of 550 millimeter. Okay, so we need to determine the value of PT now. So PT, we have the equation as follows: PT divided by 100 is equal to FCK by 2 times Fy multiplied by 1 minus under root 1 minus 4.6 R. Pardon me, it is going downwards, but I hope it is legible and you can see it, right? So when we plug the value of R as 1.458, right, and FCK as 30 MPa and Fy as 500 MPa. Here we are dealing with flexure, so we can take it as 500. Only when we are dealing with shear, we need to limit the value of Fy to 415 MPa. So I got the value of Pt by 100 as 3.56 into 10 to the power minus 3, right? So this Pt by 100 is nothing but AST by BD, right? So when I plug the values of B, D and PT, I will obtain the value of AST. So I'm going to obtain the value of AST here. So let me write the answer in a different ink. So when I substitute all the values, I ultimately got a value of 588.27 mm square. So option C is the right answer. Okay, so since there is no bending moment acting on this, so because of the torsion, it can be subjected to either sagging or hawking bending moment. So we need to provide this amount of area of steel in both the in both the bottom as well as the top region. So when I calculated the amount of bars required, considering 16 mm bars, so okay, let me take the next one only. So for 16 mm bars, so I obtained 3 bars of 16 mm diameter. Okay, so that amount of steel has to be provided both in the compression and the tension region. So AST provided becomes AST that is provided is pi by 4 into 16 square into 3. So that gives us a value of 603.2 mm square. Okay, so yeah, let me very quickly draw the the cross section. So we need to provide 3 bars of 16 mm diameter both on the compression and the tension side. Okay, so we have 300 and overall depth of 600, and then we have 3 of 16.5, and here also we have 3 of 16.5, right? So in the next question we will look at what is the spacing of transverse reinforcement that is required considering 2 leg 10 mm steps of Fe415 steel. Okay, so kindly calculate the spacing of transverse reinforcement for this particular problem. Okay, I'll be doing the problem along with you. I'll be writing down the data on the right hand side.
Answer D,
Okay.
136.5.
Okay, thank you for the response. Anybody else would like to contribute or comment? Okay, so I think we can proceed without any further delay, because we have a very important question coming up next. So I will go on writing the answers. So if there is any doubt, kindly interrupt me. So in this particular question, we are considering only torsion. So there is no shear force that is being considered. So when we multiply 1.6 into the torsion is 75 kilonewton meter, we get okay, I think here D should not be there, that was a mistake. 1.6 tu by, yeah, it has to be only 1.6 tu by B, right? Okay, let me take green. So VE is the design shear force is 400 kilonewton. Tau E is 400 into 10 to the power 3. So tau E comes out to be 2.42 MPa, right? And here PT is 0.366 percent, and corresponding to M30 concrete and PT of 0.336. Let us go back to the table and look what we get. So corresponding to 0.336 and M30 concrete, I got a value of tau C as 0.43. Okay, so I can see that 0.43 is right between these two values. Okay, so I got a value of 0.43 MPa. Now let us see what happens to our VUC tau C BD when you plug the value of B and D as 300 and 550. We obtain the value of VUC as okay, how much is that? I'm sorry, I have not calculated that. So we get a value of 70.95 kilonewton. Okay, 70.95 kilonewton, that is VUC. Okay, VU is nothing but VE, that is 400 minus 70.95. this gives us a value of VS, that is the force for which the stirrups must be designed, is 329.05 kilonewton. I hope even the participants also were able to get the same answers. 0.87, and yeah, for 12 mm ASP is 157 millimeter and D is 550 divided by 329.05 into 10 to the power 3. So we get the value of SV as 136.5 millimeter. So option C is I'm sorry, option D is the right answer. Okay, so yeah, we can go back to the diagram and we can mention how much of the stirrups we need to provide. Providing that 135-degree hook is very important. So we have 2 leg 12 mm diameter. So since it is 136, we can provide at 125 millimeter center to center. Okay, so yeah, so that is the problem. So we proceed to the
So here value of ASV is it's 226 instead of 157.
Okay.
Value of ASV.
I'm sorry, which term are you speaking about?
ASV.
Okay. ASV is, oh, okay, yeah, thank you, thanks for correcting me. yeah, I will rectify that. Okay, let me just, I had done the calculation for 10 mm stirrups, but that was not adequate. Thank you so much for correcting me. So when you consider 226.2 millimeter square, we obtain the value of 136.5 as the correct spacing. Okay. Again, in addition to this, we need to perform other checks also, that it has to be less than 300 mm, it has to be less than 0.75 d, and so on. Okay, so ultimately we can provide 127 mm spacing. Okay, so as we do usually, we will exceed the class by another 10 minutes with your permission, and we come to a very important question now, that is we are going to consider a beam which is subjected to all the possible forces, that is it is subjected to sagging bending moment, shear force, and a torque. So the first question is that determine the equivalent bending moment and shear force due to torsion. Okay, kindly take 1 minute, even I will be solving the problem along with you. And there is one more addition to the previous problem. Since the depth is more than 450 millimeter, since the spacing between these two is more than 300, we need to provide side reinforcement. Okay, side face reinforcement has to be, side face reinforcement has to be 0.1% of the gross area. Okay, so I request you all to just no, it has to be this, the effective depth. So I request you all to just calculate. So this I got as 165 millimeter square. So along with the longitudinal reinforcement for moment and for shear, we will have to provide we need to provide 4 bars of 8 mm diameter, so that will safeguard the beam against the torsion. Okay, so kindly make this addition also. Okay, so this will be 2 of 8 mm, and here we are going to provide another 2 bars of 8 mm. Okay, okay, yeah, and sorry for the interruption, we can proceed with the question please now. So we need to determine the equivalent bending moment and shear force that is caused in the beam due to torsion. Okay, and consider all the forces as factored values. I will be solving with you so that we can save time and learn together.
Answer A.
Okay, thank you for the response. So let us solve the problem and see what is the right answer. So here we have the expression for equivalent bending moment, that is torsional moment is 80 into d by b is 2, so we can take it as 3 by 1.7, which gives us a value of, yes, 141 is the right, yeah, 141.2 kilonewton meter. Okay, and Vt is Vu is we have the shear force as 60 kilonewton, 60 into 10 to the power 3 plus 1.6 into Tu. Tu is 80 into 10 to the power 6 by B is 300, so we get the value as 486.67 kilonewton. So I believe you can just appreciate how much the torsion is detrimental to the beam, because just by inducing a torque of torsional moment of 80 kilonewton meter, so the shear force has increased significantly from 60 kilonewton to 488, I think, which is, it has increased by more than 600% in this case. So just, so the correct answer is 141.2 and 486, so option A is the right answer. So for this, as we have done earlier, we need to design the longitudinal reinforcement. Okay, kindly take 3 to 4 minutes and we will design the longitudinal reinforcement for this particular beam. Okay.
Answer C.
Okay. Yeah, thank you for that very quick response. So yeah, so we can I'll start solving the problem, right? So Okay, so I think we can start solving the problem. So the answer is, it is partially correct, but there is a catch, in this, in the solution that I have developed. So I, request you to follow it carefully. So we have, we have different modes of, the development of stresses within the beam when it's subjected to torsion. Okay, so I just want to show you. So these equations, they are developed based on this skew bending theory. So here here ME1 corresponds to mode 1 of the bending, and here mode 3, ME2 corresponds to mode 3. Okay, so that will be the basis for our calculations. So MU1 is equal to 120 plus 141.2, that is 261.2 kilonewton meter. Okay, and here mu by bd square, I got a value of 2.878. okay, MPa, and here Me2 is it is basically this mode 3 of bending. Okay, so M2 minus MT minus MU, so that is 141 minus 120, so I got a value of 21.2 kilonewton meter. Okay, and correspondingly I got mu by bd square as 0.233. okay, so when you substitute in that equation for PT corresponding to this mu by bd square, I got a value of 9.128 into 10 to the power minus 3, and the corresponding value of AST, as you mentioned, it is absolutely right. I got a value of 1506.07 mm square. Okay, and then when we consider this E2 value, so corresponding to mu by bd square of 0.233, I got a value of PT as 6.5 into 10 to the power minus 4, and the corresponding AST was 107.5 mm square. But the thing is, since it is undergoing this bending as per this skew bending theory, so here it is mentioned that the top bars, they can be subjected to tension. Okay, so whenever the longitudinal bars are have the tendency to undergo tensional stresses, we need to design them for a minimum AST. Okay, so what I have done is that I have consulted the clause for minimum AST, that is 0.85 BD by Fy. okay, so based on this I got a value of 337.95 mm square. Okay, so I request that whenever you are designing for this Me2 value, so we need to provide the minimum AST, so that will take care of the the minimum steel that is required whenever it is subjected to tensional stresses, tensile stresses. Okay, so the correct answer is option E actually. Okay, option E is the right answer. Okay, So correspondingly, like I have provided okay, so I have provided 5 bars of 20 mm diameter on the tension region. So here AST provided is 1570.8 mm square, and here I have provided 3 bars of 12 mm diameter. Okay, so here AST provided would be, so this AST provided is required because we need this to calculate the shear resistance provided by the concrete. Okay, okay, so this is the longitudinal reinforcement. We will design the side face reinforcement also, but prior to that, let us take up the design of the transverse reinforcement considering two-legged stirrups of 12 mm diameter. Okay, kindly take 5 minutes. Even I will be solving the problem along with you side by side. Kindly consider this two-legged 12 mm stirrups. Calculate the spacing. Okay, do we have the answer? Okay, anybody?
Answer B.
Okay, thank you for the response. Yeah, thank you. So PT would be 0.952, right? So again, once we convert the torsion into equivalent moment and shear, it essentially becomes a bending moment and shear problem. So we are going to run through the steps once again. Again, tau E nominal shear stress is VE by BD, that is 2.95. It is less than tau C max. Then you have PT, and here AST we are considering only the steel in the tension region. Though we are providing this steel in the compression region 337, anticipating tension to develop in this region, still we are going to consider only this steel in the tension region, okay, for the calculation purposes. Okay, yeah. So yes, we have 0.952, and for M30 concrete and PT is 0.952. Let us see what is the value of tau C. Okay. Yes, for a percentage of 0.952, so it has to be very close to 0.66. Okay, so I got a value of 0.647. okay, tau C is 0.647 MPa, right? So the value of VUC is tau C BD, so that is equal to 106.7 kilonewton. Okay, right? So after this we need to determine what is the force for which we are going to design the stirrups. VUS is equal to VU minus VUC, that is 486.67 minus 106, so that gives us a value of 380 kilonewton. Okay, kindly check those who are attending the session, and also those who will be watching the recording, kindly check that you are also getting this value of 380 kilonewton. Moving on, when we plug the values here, 0.87, Fy as 415 MPa, ASV as 226.2, and D as 550, and VUS as 380.9, we obtain the value as spacing as 118.2 millimeter. Okay, so option B is absolutely right. Okay, option B is the right answer. Thanks for the response. Okay, and yes, so we will go back, since it is 118.2, even though it is closer to 125 millimeter, we are going to provide the stirrup spacing on a conservative side. So conservative sides we generally prefer as multiples of 25 millimeter, because 25 millimeter is approximately 1 inch, right? Approximately 1 inch. Okay, so that is more desirable in the field. So we are going to provide 2 leg 12 mm diameter at 100 mm center to center. Okay, in addition to this, we need to provide the side facing the side face reinforcement. Okay, so that side face reinforcement has to be 0.1% of BD. Okay, so that, as we calculated in the earlier problem also, that was 165 mm square. So when we provide 4 bars of 8 mm diameter, what would be the AST provided? Okay, let me quickly calculate that. So it is 201 millimeter square. Okay, so we are going to provide 8 bars, 2 on each side, so totally there would be 4 bars. Okay, so this would provide adequate resistance against the torsion. Okay, 2 of 8 bars. Okay, 2 of 8 bars. Okay, and along with the spacing that we have calculated, that is 118.2, we need to check for other provisions also, like let me jot down the spacing here. What should be the minimum spacing? We have different values. We have 300 okay, and then we have x, and x is the center to center spacing of the stirrups. Then we have sorry, I think it's x1, this has to be x1. Then we have x1 plus y1 by 4. Okay, I'm going to just write down the value so that you can check at your home later on. So considering a side effective reinforcement of effective cover of 50 on both sides, I got x1 as 232 millimeter, and I got x1 plus y1 by 4 as 191 millimeter. So among all these values, we have the spacing that we have provided is much lesser when compared to these values. So ultimately we have this this has to be the reinforcement. Okay, so with that I think we come to the conclusion of this particular session. Okay, I'd like to thank you all for joining. So one concluding remark is that though the design for torsion appears quite complicated at the beginning, once we resolve the torsional moment into equivalent shear and equivalent bending moment, it becomes very similar to the problems that we have dealt earlier. So I hope that you will practice the problems, and again I will I would like to assure the participants that we are working on the detailed solution for the assignment, and we will be providing with you as soon as possible. Okay, with that, if there are no comments, we will conclude the session for tonight.
Okay, sir. Thank you so much.
Yeah. Thank you so much for joining. Okay, good night. We'll see you. We'll meet again next week. We'll be starting with the design of columns. Okay, I look forward to meeting you all next week. Okay, thank you.
Excuse me, sir.
Yes.
Our examination venue, when will it will be decided?
Okay, I think you need to ask the administrative people, because we are just because we are just involved with the tutoring. So I suggest that you contact the NPTEL team, and they'll be able to help you. Definitely they'll get back to you within 1 day. So please consult with them.
Okay, sir. Thank you so much.
Yeah. Thank you. Good night.
Good night.